No. Alright, what's up, class? Okay. So today, we're going to be looking at separable differential equations. And as you can see by the name, they're equations. But also, they are separable. So as you can see, we have two variables here. We have an x and we have a y. Now it's great, but what we want is to have them match on each side. So the x would be with the x, the y to be with the y, and so on and so forth. So to do that, first, we're going to take this x here and multiply it to the other side. So we're going to have dy equals negative x e of y times dx. So great, now we have the x's together, right? But we still have a y that's in the wrong place. So what can I do to get rid of that? I can divide the whole thing on both sides by e over y. And that's going to leave me with dy over ey, but that you don't really want, that just gets confusing. So I'm going to simplify that to be 1 over ey dy equals negative x d of x. I'm going to be saying x and y a lot in this video. Okay, so now that we have this, how do you get rid of dy dx and just have y? So we can figure out what this equation is equal to. Integration. So I can just integrate this side and this side, and no advice. This gets a bit confusing as well, so I'm just going to simplify this to be e of negative y goes from the denominator to the numerator, the exponent becomes negative as a result. So, out there. The integration of e to the negative y, e is just e, the negative y, that's going to be a negative, so I'm going to multiply the whole thing by negative and end up with negative e of negative y, and on the x side, negative x, that's going to turn into an x squared. To get rid of the coefficient, to have this should be negative x, it's going to be negative 1/2 x squared plus c. Plus c. We're going to call it c1 for now because it's going to be subject to a lot of stuff way down the line. Now as you can see here, we have a negative on both sides of the equation. So the cool thing about that is I can just knock them both out. Makes it simpler when we get to like other stuff. So now that I have an e, I just want to isolate for the y. How do I get rid of this e? Exactly. ln. So multiply ln on both sides of this equation is going to give you ln of e negative y equals ln of 1/2 x squared plus c2, because we multiply negative on both sides, and negative times the constant is going to be c. So, okay, so this ln and e is going to knock out, and that's just going to leave me with a negative y equals ln plus all that. I'm not going to say that gets a lot soon. And if I just want to isolate for y, I just move this negative over here. So that's going to end up being a y equals negative ln 1/2 x squared plus c. Okay, so now that we have this, which is known as the general solution, what if I want to find what c is? Well, I have the initial condition of y of 1 equals 0. Forgot to write that earlier. Okay, so this is going to be x is going to equal 1, and y is going to end up equaling 0. So we just plug those values into this equation. We're going to end up with 0 equals negative ln 1/2 times 1, because we're plugging in 1 for the x, 2 plus c. Okay, so again, we have ln on both sides. So what can we do? Exactly, e. So have e on both sides. So we cancel out. E of 0 is just going to be 1. So we're going to have 1 equal negative 1 squared is just 1/2. 1/2 plus c. And then, as you can see here, what minus 1/2 is going to equal 1? Well, 3 halves, 1 and 1/2 minus 1/2 should be 1. So C is going to equal 3/2. So now that we have our initial condition finished, the final equation is going to be y equals negative ln 1/2 squared plus 3/2. You know I just solved that. Alright class, that was a good break. Oh hell no.
Wait, come back.
No, that Pikachu's wearing a gang outfit. Where did he keep coming from? I'm gonna get shanked. That's not what Mr. Chow would do. I'm back. Okay, so now we're doing the same thing, just applied to an actual word problem. So, in this one, a cold Pikachu. Sorry, I didn't know he was gonna be here today. It's taken out of the fridge and warms from an initial temperature of 45 degrees to 60 degrees. Now the room is at 80 degrees, and this is all happening in 8 minutes. So what we want to find out is using Newton's law of warming, which conveniently someone wrote right here. We want to find out what Pikachu's temperature is going to be after another 8 minutes. So what Newton's law is that this is a proportional constant, and this is going to be proportional to the temperature of the room minus the temperature of the surroundings. Now, based on the problem, we know the temperature of the surroundings is 80 degrees, right? So that's the only thing we know so far in comparison to the equation. So that's going to equal dt equals dt equals k times t minus 80. That's a good start, okay? So, also this time temperature, by the way. So, now what we want to do is we want to isolate the t's again, just like we did with x and y. So we're going to multiply this dt to the side and then divide this t minus 80 over here, so the t is with a capital T. So dt, 1 to t minus 80 times dt equals k over dt. Remember, we're going to integrate again. So it's going to be integration 1 over t minus 80 dt equals integration of k dt. That's going to be ln t minus 80 equals kt plus c. Okay, so now we have an ln on both sides, but we want to isolate the t. So we're going to have e on both sides. And the important thing to know about e to a constant is the c is just going to be multiplied to the e. Hold up, look at the light. Alright, time on. Okay, so we're going to have t minus 80 equals c2 e k t, okay? So now we're going to get rid of the absolute values, so it's going to be t minus 80 equals plus minus c3 e k t. Put the isolate the t, so 80 plus c3 e k t. It's going to be the general solution. Now some important things that we can do that we want to also know, is that t of 0, so time of 0 is going to equal 45 degrees Fahrenheit for Pikachu. T of 8 minutes is going to equal 60 degrees Fahrenheit. What we want to know is T of 16. So the temperature after another 8 minutes on top of the 8 minutes. What does that equal? Equals question mark Fahrenheit. Okay. So the funny thing is we have 3 values, or 3 times here, and we also have 3 values in our equation that we want to know, being c, k, and t. See how that works out? So the first thing we're going to do is plug in t of 0, which is going to equal 45, equal 80 plus c e k 0. Now 0 times k is just going to be 0, e to the 0 is 1, multiplied by a constant is just c. So we're going to have 45 equals 80 plus c. So what plus 80 is going to equal 45? Well, 80 minus 45, C is going to equal negative 35. That's C down, okay? So now we rewrite the equation with respect to T of 8 equals 6C, which is equal to 80 minus 35 EK of 8. Okay? So just subtract 80 to 60. So that's negative 20 equals negative 35 EK AK. Okay? Alright, writing's getting a little messy here. So now I want to divide 35 by both sides, and negatives are going to cancel out. So that's equivalent to 20 over 35 equals E8K. And how do we get rid of E? ln. So that's going to be ln of 20 over 35 equals ln of E to the 8K. ln and E are going to cancel out, so you're left with 8K equals ln 20 35. Okay, now it's time to get my calculator. My calculator, I know K is equal to 1/2 ln 20 over 35, or in other respects, negative 0.06995. So that's going to be K. So now we just have one last value we need to find. So T is 16. We don't know what it's equal to, the exact value, but we know the equation is equal to. So plugging in this for K, we're going to have 80 minus 35E to the negative 0.06995 times 16, which is T. And that is all going to be equal to, let me get my calculator again. That's going to be equal to 68.57 degrees Fahrenheit, which will be Pikachu's temperature after 16 minutes. And we know all this thanks to Newton's law of cooling and separable differential equations. I did it. I want to get a shirt.